Okay, hello COP1000 students. This is Dennis. I am going to do a short video here about functions. So the first thing I'm going to do is I'm going into NEC IDE. I'm going to write my comment header like I always do. These are my pre-processor directives, or my pounds and my defines. Down here is where I will write main, and I like a comment after every ending mustache. This is new. I like to put a divider line after main. In this discussion, we're going to talk about functions and function prototypes. So first thing I want to do is just maybe start a section where I can give you some notes. So I'm going to put a comment in here like so. And the first thing that I want to do is basically define what a function is. And that would be a function is a block of code that performs a single task or action. We've seen functions such as printf, scanf. They do like one thing. Let's introduce the concept that there are two types of functions. And those two types of functions are built in. These are the things we've been using, and then the user-defined functions, which is the topic for this lecture. So we're going to start with maybe deciding, like, why in the heck would we want to have these user-defined functions or functions in general? And that would be, you should use functions because they make your code easier to write and understand. They allow your programmer to have the ability to divide the functions among many other programmers and get the task done. Functions, as we know, can be recalled. We can call pause and clear the screen over and over again. And functions work well when you're dealing with teams. A function, just like a variable, an array, is going to have a name, and the function name should be self-documenting. So functions are going to be function names are going to be rather long, and a function name should be an action word. Calculate payroll, display the menu, add the values up. Those type of words. And remember, as always, function names or anything you make up will always be written in camel case. Except for constants. A function has three parts. So every function has three parts. Part A is the keyword void. This is a new word, or a data type. But when I say a data type, I mean int, double, float, char, whatever the data types that we might be using. After the data type or the keyword void comes whatever you name your function. This is the part you make up. And then after this part is going to be something called the optional parameter list, and it's going to be something inside of parentheses. Give you a quick example. Void my function. Okay, what you see right here would be a function definition. Starts with part one, the keyword void, part two, the name of the function, and part three, an optional parameter list. And as you can see, this time I left it empty. And then in here, where the body of the function would go, Next note. That would be how you have these things called functions. How would you call them? Well, you know how to call a function because you've been doing it this semester, and you would call a function simply by writing the name of the function followed by the optional argument list. How have we called printf? We just write printf, and then in the parentheses, we have the format string and the optional value list. So that would be your argument list. Okay, so today's topic is user-defined functions, and just wanted to make sure you understand that there are two types of user-defined functions, and we're going to categorize those as value returning and non-value returning function. And a non-value returning function is called a void function. If it is a value returning function, in the function header, part A, there will be a data type. If it is a void function, the keyword void will be here. A value returning function returns a single value, what we're going to call through the function, and a void function does not return anything through the function. Next statement is we write these functions, where do we place them in our code? And that answer is fairly simple. Where do you write your functions? You write them below main. The below main, not above main, but below main. So main is right here, starts, ends. Notice I put this divider. This is below main. So you write your functions down here, down here. Okay, now we have a problem. Since we write our functions down here, inside of main, if we call a function like my function, so we call that, when main runs, it's going to run top down. It's going to see this word my function, and it's going to not know what it is because it's going to be defined down here. So we write things down here. We have to prototype them here. So for example, so if you happen to have a call to a function called my function, you would write my function below main. So here's the three parts: void, name, optional parameter list. This function, when I run it, simply says you're inside of my function and pauses the screen. Prototyping, what you do is you copy the very first line of the function, that's called the function header, and you place it right there underneath prototyping. Last thing you do in a prototype is get rid of the mustache and replace it with a semicolon. So the function prototype is from the beginning of the function header to after the left paren, followed by a semicolon. Now when this runs, main will know what this is all about. Main will know what it's all about. All right, next. So when you run functions, the question would be, what happens after they're done? What happens after they end? And that is pretty simple. When I run a function, what happens is control is transferred to the line after the call of the function. So here in main, top down, I hit line 48, I come down in here, come back, and I'm on line 40. I'm sorry, I hit line 47, do this, and I come back to right here, or line 48. Come back to the line after the call to the function. Okay, and then I believe my last topic before I demonstrate would be a concept called scope. Scope. Very important concept in any programming language. Any programming language. A scope of a variable is where the variable, I like to call, lives or exists. The scope of a variable is the beginning and ending mustaches of any function. So if I had a variable down here in this area, int num1 comma num2, let's just give these some values. We'll call this 5, and we'll call this 2. So in main, I will have variables called num1, num2, and down here in the function, my function, I could also have variables, and they could be the same name if I wanted them to. And down here, this could be 22, and this could be 25. These variables, num1 and num2, live in main. The scope of these variables are main. These two variables, num1 and num2, live in my function. The scope of these variables are my function. This num1 and this num1 are complete different locations in memory. Notice they can hold complete different values. Once this function, my function, ends, num1 and num2 that belong to this function are gone. Just like in main, when I close main, the values are gone. The values are gone. Okay, what I'm going to do is I'm going to stop this video right here, and then I'm going to create part 2, show you some code.